Let's continue with the planarity testing. Before applying any algorithms, we can use some pre-processing to simplify the task. For example, if the graph is not connected, then we can consider each component separately. If the graph has cut vertices, then this graph would be planar if and only if each of its blocks is planar. So then you would have to test each block separately. You can remove the loops and parallel edges. And also each vertex of degree 2 and its incident edges can be replaced by a single edge. Let's look at an example. I'm going to work on this large graph on the top of this slide. And we can apply what we talked in the previous slide. For example, here, there's a cut vertex. Here's another cut vertex. So we can basically separate this graph into its 3 different blocks, as you can see here. So we will examine each of these blocks separately and try to find out if they are planar or not. Also, we can apply some simple tests. For example, if the total number of edges in a graph is smaller than 9, or the total number of nodes is smaller than 5, any such graph must be planar. Similarly, another theorem says that if the number of edges is greater than 3 times the number of nodes minus 6, then this graph would be non-planar. So these are some results that we can directly get from just the number of nodes and number of edges. If these tests fail to resolve the question of planarity, then we will need to use more elaborate tests. So let's examine these different components one by one. So here is the first one. We said that we can remove any nodes of degree 2 by just replacing its incident edges and that node with just a single edge. So we replace this node and these 2 edges with this edge here. We can do the same thing for this vertex and the same thing for this vertex as well. So here is the next step. Now we also said that we can remove the parallel edges. So this edge here can be removed because we have 2 edges between the same node pair. Same rule applies to here and here. And as a result, here is our simplified graph. Now we have again some nodes as a result of the simplification, some nodes that have degree 2 here and here. Similarly, we can replace them with just one edge. And eventually we get parallel edges. So one of them can be removed. And at the end, we end up with this graph, much more simplified version of this one. And since the total number of nodes is smaller than 5, we can say safely that this is a planar graph. We actually see this. Going back to the original graph, so this was the first part that we found out that it's planar. The second component of this graph is already planar because it has only 4 nodes. And finally, this third part, if we can find out that this is also a planar graph, then we can say safely that the original graph is also planar. So let's look at this graph. So we apply these simple rules again and again until we cannot simplify the graph further. So here are 2 nodes of degree 2. eventually we can replace them with single edges. And then we have these parallel edges. We can remove one of them. Here's another parallel edge pair. We can remove one of them. And the resulting graph has 1, 2, 3, 4, 5, 6, 7, 8 edges. Since the total number of edges is smaller than 9, according to one of our rules, this graph must be planar. So, as you can see in this example, it is possible to find out that a graph is planar just by applying these simple rules again and again.